Let's determine the geometry of a molecule where the central atom has 2 sigma bonds and 2 lone pairs of electrons. So given the electron configuration of oxygen, in the excited state, one electron in a 2s orbital jumps to the 2p orbital. And then 1s and 3p orbitals are hybridized to form 4 sp3 hybridized orbitals, where 2 orbitals hold the 2 lone pairs and 2 are used to form the sigma bonds with the hydrogens. So the resulting orbital behaves 25% like an s orbital. And using VSEPR, we maximize the distance between the lone pairs and the bonds due to electron repulsion. So we ignore the lone pairs when we draw the molecular geometry. So this molecule has a bent geometry, where the angle between the bonds is slightly less than 109.5 degrees due to the additional repulsion from those lone pairs. And oxygen is sp3 hybridized.